What's up guys, welcome back to the channel. In this particular video I will explain the problem find all four sum numbers. This problem is again a standard DSA problem and asked by many companies guys like Amazon, Microsoft and Flipkart. So make sure you stay tuned till the end of the video. Starting right away from the problem statement, so it says that you are given an array A of integers and another number k. Your task is to find all the unique quadruple from the given array that sums up to k. What is a quadruple? So a quadruple is basically a set of four values that comes from different indices. So let's say I have an array 1 2 3 4 5. Guys, generally a quadruple is anything that consists of four parts, and in terms of arrays a quadruple is basically a set of four elements from an array. So let's say I pick this element, this one and this one. So 1 3 4 5 is one of the quadruples of this particular array, right? Apart from this, there are multiple quadruples possible, like I can write 1, 2, 3 and 5. Also I can write 1, 2, 4 and 5. So there are multiple quadruples possible. This is about quadruple guys. Now our task is to look for all the quadruples that sums up to k according to the problem. One note is also given that quadruples which you return should be internally sorted. For example, if we have this particular quadruple, so q1 is going to be the smallest value and q4 is going to be the largest value, right? Now one example is given here. Let me explain this example guys, but before that I want to remove everything from this particular page. So see, now we are given an array which contains the value 0 0 2 1 and 1. Guys, our task is to look for all the quadruples which sums up to 3 according to this particular example. So see, I can see two quadruple here. First one is 0 0 2 and 1, right? So let me write here 0 0 2 1, and also the second one is 0 0 2 and this one, right? So I have 0 0 2 1. But see, both of these are representing the same set of values, right? So I'm not going to consider both of them. I have to consider only unique quadruples. This is what the problem says, right? So let me remove one of them. I'm only going to consider this particular quadruple. So according to the problem, we have to return the quadruple in sorted manner. So I am simply going to sort this particular quadruple and the output is going to be 0 0 1 2. Guys, this is the output for this particular example. Now I hope you have understood the problem well. So without any further delay, let's talk about the solution now. Okay, so I have written one example here, and see guys, according to the problem our task is to look for all the quadruples in the given array that sums up to k, right? So see, from the problem explanation, the first approach that will come to your mind is we can try out every possible quadruple from the given array, and then we can look for those quadruples that sums up to k. Make sense? So let me show you guys. This is the code that I have written. And see, here I am using four nested loops in order to find every possible quadruple. Then I am checking this condition if the sum is equal to k, right? Like this is the given sum, or I can write k here. If the sum is equal to k, then I can simply store the quadruple. But always keep in mind that before storing the quadruple, I have to sort the quadruple as well, right? I want the quadruple to be in sorted manner. So see, how this code works, let me explain guys. First of all, I'm going to change the color, and see, for any quadruple we have four numbers, right? Okay, let me change the color guys. For any quadruple we have four numbers. Let me erase this so that I can write with another color. uh, Now we have four places for any quadruple, and I want the sum of every number of the quadruple to be equal to k, right? Now how I can do this? So first of all, let's look for the first value of the quadruple. So in the first loop, when I come inside this loop, then I will get the first value, which is nothing but array of I, right? After this I will come to this particular second loop, and inside this loop I will get my second value, which is array of j, right? And guys, see, once I have got my array of I and array of j, then inside this loop I have to look for rest of the values of the quadruple so that I can get the sum k, right? So here I will get my third value, which is array of k, and then I will look for the fourth value, which is array of l. See, this I, j, k and l are the pointer which are not constant, which are going to change and iterate over the array, right? So this means that this particular statement is going to give me every possible value for the quadruples from the given array, right? So this is the given array for us. Now what is the time complexity of this code? See, we are running 4 nested loops, so the time complexity is going to be O of n raised to the power 4, right? But this is not going to work for large inputs. We can optimize this particular complexity. Now let's see how we can optimize this particular complexity. So see guys, what I have explained in the like this particular explanation, we have 4 values for the quadruple. We have 4 values and I want the sum of all the values to be equal to k, right? So guys, first of all we have to look for the first value, so I can simply run a loop. I'll say that for I equals to 0, then I smaller than n, then I plus plus, right? Inside this loop I will get a value which is array of I. So array of I is the first value of the quadruple. Now as I is going to iterate over the array, so I will get every possible value for array of I, right? After this we have to look for second value, so I will again start a loop. I will again start a loop. Guys, we are talking about the optimal approach now. Just don't get confused that I am writing the same code again which was similar to brute force, right? So this is how I can get every possible value of array of j, right? Array of j. But see, there is one catch that we need to understand, that for the first value we are starting from this particular point, right? But for the next value we can't start from the same point. We have to start from the next point because we don't want the values to be repeated, right? We want only unique quadruples. So if I start from this 10, then I will get 10 and 10 again, but I don't want this, so I'll start my j from I plus 1, right? I plus 1. Now see, we have got 2 values and now we are left with 2 values. So now inside this, I want 2 values with sum up to like k minus array of I array of j, right? Let me write this statement in a more better way. So let's say this is x and this is y. So I'll write x plus y equal to k minus array of I minus array of j, right? Array of j. Now when I'm in this particular loop, so array of I and array of j are constant, right? So let me replace this particular value with a constant. So let me write x here. Now x plus y equal to, okay, I can't write x guys because I have already x here, right? So let me write m here. So now I want you to notice one thing, that I want a pair, I want 2 values or a pair with sum up to m, right? So this is nothing but two sum problem, guys. Two sum problem, again a very popular standard DSA problem which is asked by many companies, and this is the first problem on lead code, guys. And whenever you want to start coding, so I recommend this particular problem to be solved first, right? So this is again a very popular problem, so I can simply write two sum here. If you are someone who don't know how we can solve this particular problem, then don't worry guys, I'm going to explain this particular problem in this video only, right? So see here, now you can see that I have to look for 2 values with sum up to k. Once I have done this particular task, so I can simply replace the code. So in order to do this task, guys, the first approach will be again very similar to this one. I'm running 2 nested loop here and this is going to give me O of n square complexity, right? But the two sum optimal solution says that we can do the same task in just O of n. So when I do this in O of n, then the total complexity of this particular approach will be O of n cube, right? So now we will talk about how we can find a pair with sum up to m, right? Or any given value. Sum m is basically a constant, right? So we have to look for 2 values with sum up to the given target sum, and once we have done this, we can simply replace that particular code with this particular line, right? So now let me show you how we can find a pair with the given sum. So one example is given here, guys, and for this example we have to look for all the pairs which have sum equals to 15, right? Now guys, see, first of all let me tell you what we do. After this I will definitely talk about why we do this, right? So the first step is to sort the given array. So when I sort this particular array, I will have 2, 3, 4, 5, 7, 8 and 10, right? This is the array that we have after sorting. Now we are going to use two pointer approach. So there are multiple approach to solve this particular problem, like a map based approach, but I am going to explain the two pointers approach, right? So I will explain the two pointers approach. For this approach, guys, see, first of all, I'm going to have one pointer here which is low, and then I will have this pointer which is high at this point, right? And every time the sum is represented as array of low plus array of high. So let me write this. I have array of low plus array of high. This is how I can represent the sum at each time, right? Now guys, I am going to compare this particular sum with this value k, right? Because I want my sum to be equal to k. Only in that particular case I can say that okay, this is my pair, right? So this is my pair with sums up to k. So there are three possibilities. The first one is if my sum is equal to k. This is the main goal that we want, right? After this, the second possibility says that if my uh, sum is something which is smaller than k, and then the third possibility is if my sum is greater than k, right? So I can simply cover this particular possibility is else case. So else case basically talks about if sum is greater than k. So now let me explain what we are going to do in every case, right? So guys, see here. First of all, if my sum is equal to k, in that particular case, I have got the answer. So I'll simply say that, okay, store answer, right? This is the first case. The second case says that the sum is smaller than k. So let me explain, guys. See, for the current value of array of low and array of high, you can see that I have 2 plus 10 as the sum, which is nothing but 12, right? If I compare this sum with this particular value of k, which is 15, so you can see that sum is smaller than k. Sum is smaller than k, which means that this particular condition is true. So what we are going to do is, see guys, we have to increase the value of sum. We have to increase the value of sum so that we can make our sum towards k, because sum is currently smaller than k. So how we can increase the value of sum? You can see that this is a sorted array. This is a sorted array. So I will simply say that do low plus plus. And low plus plus is basically going to look for larger values, right? Because after this 2 we have larger values. So I will simply say that okay, at this point we will do low plus plus. After this, there is one more case which is sum is smaller than k. So let's say guys, sum is smaller than k. This means that we have 18 here. We have 18 here. So now you can see that 18 plus 2 is something which is 20, and 20 is greater than k. So let me remove this, and here now our sum is greater than k. So sum is greater than k. So what to do in this particular case, guys? Now you can see that we have larger value here, and we have to make the sum smaller so that sum can be equal to this particular value k, right? So I have to make the sum smaller. How I can do this? I can simply decrease the value of high, because this is the largest value, and before this every value is smaller than this particular value, right? So I'll simply say that in this case do high minus minus. Guys, these are the three cases that we need to handle, and once we have done this, we are going to perform this particular thing in loop while my low is smaller than high. And this is how two pointer approach works for finding pair with given sum, or in short we are going to say two sum problem, right? Now let me show you the dry run for this particular example. We have 2, 3, 4, 5, 7, 8, and 10, right? So see guys, first we have low here, and then we have high here. This is my low, this is my high. So what I will do is I will simply you can see that the current value of sum is equal to 12. So I will do low plus plus, right? So in the second iteration my low will come here. Now you can see that I have 13. So again you can see that sum is 13 and k is 15. So sum is smaller than 13, right? So sum is smaller than the value k. So at this particular point again I will do low plus plus. So my low will come here, and now you can see that this is 10 plus 4, right? 10 plus 4 is again you can see that 14. 14 is again smaller than 15. Now at this point guys, I will do one thing. I will simply increase the value of low again. So now my low will come here, and now you can see that guys, I have got 10 plus 5 equals to 15. So 15 is equal to 15. Now we have arrived to our condition, right? So this is how this particular code works, guys. So now we just need to replace this particular code with this particular line here. So once we have done this, our task is done. And talking about the time complexity, so this is now O of n raised to the power 3, right? And now guys, I want to talk about very important thing, which is how we are going to handle duplicate values, because duplicate value is going to create a problem, right? And apart from this, there is one more thing, which is the space complexity of this particular code, right? So space complexity I will tell you when I will talk about how we are going to store the values, like we are storing quadruples to answer, right? But this is very important step, how we are going to store. So now let me explain how we are going to store the quadruples. So at this point, let me explain, guys. This is the main pseudocode that I have written here, and guys, we are still missing something, which is how we store value whenever our sum is equal to k, right? So guys, see, we have our 2D answer list here, and whenever we have got our answer, so we just need to do add answer.add. So different languages have different syntax. I'm simply going to write array of I, then array of j, then array of low here, then array of high, right? So guys, I'm not getting much space here, but I hope you understand this. Array of I, then array of j, then array of low, array of high, right? So guys, now the question is, we have to return every quadruple in sorted manner, right? So is there a guarantee that this is in sorted manner? So let me explain, guys. See, we are using a two sum logic, and you can see that whenever we write two sum logic, so first we sort the array. So there is one more step, which is sorting, right? And before pasting this particular code in this particular like place, or using the logic for two sum in this particular problem, we have to sort the array first, right? So we are sorting the array, and once we have sorted array, so you can see that first we have I in the array. First we have I, then somewhere after I have j, because I am initializing j after I. Then somewhere after j I have low, and then I have high, right? So guys, this is what we need to take care of. You can see that I have I, j, low and high. So this means that this quadruple is always going to be in sorted manner, right? After this, what we need to do is we simply need to do low plus plus and then high minus minus, right? Then once we have found the pair, then we are going to look for the next values, isn't it? But there is a problem when we do this. First of all, let me give you an example where problem is going to take place, right? So I have 0 0 1 1 1 1, and then I have 2 2, right? This is the array that we have. And see guys, for this array, let's say somewhere, okay, let me write one more 0 here, and let's say somewhere while performing this operation, my low was here and my high was here, right? So this is my low, and okay, instead of taking this, guys, let me take this as low, right? This as low. And before we take this low, I have to write one more 0 here, because this is for I, this is for j. So yes, I can take this element as low and this as high, right? So guys, see, when I see one pair which is having my sum, so I'll do low plus plus and high minus minus. When I do low plus plus, see, current pair is 0 and 1. And when I do low plus plus, so low will come here, and when I do high minus minus, high will come here. So again I am pointing to 0 and 1. So you can see that again I am going to store the same pair, right? But this is something that we need to avoid. Why? Because we want to find only unique quadruples. So let me write unique quadruples. This is what the problem want us to do. So quadruples, right? So this is what we need to do. So we are going to avoid doing this, right? So I will keep increasing the value of low till I have 0, right? So how I can do this, guys? I don't have much space here, so I will write somewhere outside this particular place. So let me write here, guys. Let me write here. What I will do is, first of all, let me remove this. And then the main logic is, first of all, I have to initialize a equal to array of low, right? And then b equals to array of high. So how many times I have to increase low? Like I have to avoid all the numbers which are equal to low, right? So now my low should point to this one. So I'll say that, okay, while my low is smaller than high, this condition I have to maintain, right? And my a is equal to array of low. So in this particular case, I will keep doing low plus plus, low plus plus. This means that I have 0 here, then here I have again 0, which is equal to previous value of, then I will again increase, and now you can see that we have a different value, right? So this is what we are going to do. Similar thing we are going to do with high as well. So I'll say that while low is smaller than high, and my b is something which is equal to array of high, right? So in this particular case, I will do high minus minus. So guys, this is the logic that we need to write here, so that we can avoid duplicates, right? After this we have to avoid duplicates for like I and j as well, right? So let's say somewhere I have this array, and my I was here, so after this, if I move my I here, so again you can see that I have 0, right? So I have to avoid this. I will say that, okay, uh, I have to write one logic here. I'll simply write, if my like I is greater than 0, and array of I is equal to array of I minus 1. Like I'm pointing to this place and my previous value was also equal to this value, which is 0, right? So at this particular point I have to avoid solving for this. I will simply move to this place, which is nothing but continue statement, right? So I will write continue. I'll simply write continue here. Continue. So guys, this is how we can avoid duplicate value for I as well, and similarly we have to avoid for j as well. So I'll write j is greater than I plus 1, and array of j is equal to array of j minus 1. So once we have done this, then we can simply write continue here. Right, guys, this is the whole approach that we need to perform. Once you have done this, then your task is done. We can do some small optimizations, like say we are talking about an assorted array, right? So let's say my array is 1 2 3 86 87 and 89, right? And I'm here and I am here, and my k is the value of k for given problem is 23. So I want my quadruple which has sum equal to 23. But you can see that now a single element is something which is greater than 23, right? So after this I'm not going to get the answer, because every element will be greater than this 23, as this is a sorted array, right? So guys, this is something which we can also handle. We can write one condition at this particular point, which is the condition will be something like, if my like array of I is something which is greater than, okay, I'll write if array of I is greater than k, then I can simply write break, right? This is what we can do. Or there is one more condition. Let's say my array is 1 2 3 and we are looking for quadruple, right? So you can see that array size is something which is smaller than 4 values itself, so I can't get any quadruple. So I'll say that, okay, if my array dot size is something which is smaller than 4, then I can simply return an empty 2D list, right? So guys, these are the small optimization that we can do in our code so that our code can become faster, right? Now this is about this particular problem. This is the code in Java and Python, and this is the code in C++, guys. And now you can see that we are just using a 2D list here, and after this we have this particular like code, right? This is the main logic. You can see that first we are sorting the array, then we are simply running a loop, right? And now guys, this is the code in Python and this is the code in Java. So now I hope everything related to this particular problem is clear to you. So guys, this is all about this video. Thank you.